Okay, all I was doing today was going to go over some graphs. I went back to worksheet 24 and 25 because number 6 on 24B, you couldn't graph with the labels that were on it, so we changed the labels. This would be 6. And then I knew that number 9 also would not fit, so we're going to go ahead and do it. It would have an amplitude, a period of 8 pi. So let's just change this. Oops, wait a minute. That might not be where I want that. So 1 second. Let's figure out how to count it off. Remember, you need 5 key points. 0, 1, 2, 3, 4. So this would, 0. That's 1 of them, 2 of them, 3 of them, 4 of them, 5. So actually, I want to put 8 pi here. Okay, and then half 8 pi would be 4 pi in the middle. And then this would be half of 4 pi, 2 pi. So this x scale would be 2 pi. So 2 pi, 4 pi, 6 pi would be right here. 8 pi, and then this would be 10 pi. And if you went backwards, that'd be negative 2 pi. All right, so I'll go ahead and use this now as an amplitude of 2. It's a sine graph, so we're going to start at 0, 0. That's your first key point. And then you go to 2 pi, 2. Then you go back to 4 pi, 0. Then down to 6 pi, negative 2. And then back to 8 pi, 0. And then I'll go ahead and just sketch that sine wave. And then if we wanted to extend it, it would go back up to 2 at 10 pi. And we don't have to write the names of those points. We've already got labeled the 5 that we need. And if we went backwards on the left side, it would be down at negative 2 pi, negative 2. Okay. All right, so those were the ones I wanted to just double check with you on. Make sure you knew that I realized that you couldn't graph it the way it was labeled. Okay. The rest is good on 25B. So anyway, did anybody want to ask me anything else from 24 to 25 at this time? Josh? 8 on 25A. This one? Okay, amplitude is 3, so and period would be 2 pi. Oops. Okay, so I've got amplitude is 3, period would be 2 pi divided by pi, which is 2. Oh, maybe that's why you wanted, or so 2 pi divided by 2, which is pi. Excuse me. We had some that we did divide by pi, but not this one. All right, so pi is the period, which means we need to go out to pi 1 cycle. So this we need to label as pi over 4, half of pi over 2. 1 pi over 4, 2 pi over 4, 3 pi over 4 would be between there. Okay, it's got an amp 3, so it's going to start up at 0, 3. And then it would come down to the center line. Then down to the minimum, which would be at negative 3. Back to the center line, and then end at pi 3. So this would be 1 cycle of the graph. Okay. The key points, pi over 4, 0. We already got 0, 3, pi over 4, 0. Then we got pi over 2, negative 3. 3 pi over 4, 0. And the last one up here would be pi 3. And then you could continue the graph just by following the curve. So it goes up like that and then comes back down. And then I come back down again. And end there. Going back this way, it would end right at negative pi over 2, negative 3. You don't have to label all those. All right. All right, so then I thought we would go ahead and look at some graphs together that have the vertical shifts and the horizontal shifts, etc., or phase shifts, which is worksheet 28 and 29. And I did assign 27B, so make sure you are working at that as well. Besides just graphing, you want to remember some of the old stuff. These, I think, are quite doable, very simple. These are just amplitude changes, so these should be an easy page. There's some period changes. When you get to number 4, you need to know that that would be 1/4 for the B value. So then the period would be 2 pi divided by 1/4, so it would be 8 pi. And this is labeled just fine for that. So you know one cycle is going to happen out to here. All right, I thought we'd move to something a little harder. These are all pretty straightforward. Center line change on number 8. Center line changes on 9 and 10, but no period changes. So these don't look so bad. Then I got to like 11 and 12. Didn't know if maybe you want to look at any of these because they're reflected, etc. Not that they're all that bad. Does anybody want to look at either of these? Or do you have certain questions on 28 you'd like me to cover? And then I do want to go to 29 and do a few. Do one of these? All right. The -2 is a K. So that means your center line will be y equals -2. You have an amplitude of negative, the negative sign there means we have to reflect the graph over the x-axis, and the amplitude is 3. The amplitude is always positive. Okay, so if your center line is at -2, I'm going to dash that in, and your amplitude is 3, then you have to go 1, 2, 3 above there, so we're going to stay between 1, y is 1, and then down from the center line 1, 2, 3, 1 and -5. So when you're doing your amplitude, you want to know that you count 3 from the center line above and 3 below. Then I say, all right, I got a sine wave, which means it starts at its center line, then it goes up at pi/2 to its max, to its center line at pi, down to its min at 3 pi/2, and back to its center line at pi/2. So this would be one cycle. And that one cycle, we need to provide the 5 key points for it. The 5 key points would be 0, -2, pi/2, 1, pi, -2, 3 pi/2, -5, and 2 pi, -2. After that, you could extend the graph. And that's all you'd have to do for that. And then over here, you could go back, I guess, to, does that say -pi/2 there? Or is it not even labeled? So I guess that's enough. Okay? All right, let's go to 29. This is worksheet 29. She's number 14, just super flat graph. Really not that bad. I think the worst one would be, maybe we'll go on to like 15, where you don't even have a graph thing given to you, and that is a phase shift graph. Do we want to do that one, or it's really not a real bad one. I can see worse ones, like number 17 is a lot tougher than this one. Let's do 17. Okay, so 17 has a K value, has an A value, doesn't have a B. B is 1. And it has a C, which would be a phase shift. So the phase shift is going to be right pi over 6. The K value or center line will be is y equals -2. The negative sign here for the A value means you need to reflect over the x-axis, and the amplitude is just a half. Okay, so here's how I'd probably start it. I would draw a horizontal line and a vertical segment. Since we're phase shifting to the right, I'm just going to put that over here. Oh, but I just thought about it. Wait, we have a center line change. It's going down too. So I might want to just grab this and slide it down. So if that's -1, then -2, and I have an amplitude of 1/2. Oh, maybe I better spread those out a little bit more, just because I got to go between them because the amp's only 1/2. So I'm just trying to have you think about what you need to do so it gets your graph be easier to do. -1, I'm going to spread these out. Yeah. Yep. Because your graphs are going to have whole numbers on them. You're going to have grids. Yes, you need to show that it's between. I just extended that a little bit. So I was asked if we could just label our tick marks with those values. No, if they're halves, I want you to show they're between whole numbers. You should have, just like you would never plot points. When you do a XY coordinate, you label them in whole numbers. You don't label them in decimals, right? So, yeah. Anyway, so if you're doing a half and your center line's at -2, you actually need -3 on here. Okay, now, where are our marks? Our halfway between there. You can write -2.5 there if you'd like. I don't care about that. Just show that it's between, of course, -2 and -3. Oh, is that all you meant? Okay. Yeah, I'll go above here, 1.5, -1.5. That's fine. I just want you to show where the whole part is, though. Okay. Yep, that's fine. All right, and then extend. Let's see, what was our period? The period is just 2 pi because there was no b value. All right, so I'll just go out to 2 pi. I'll cut that in half, which would be pi. Half of pi would be pi over 2. And then 1 pi over 2, 3 pi over 2. 3 pi over 2 would be between pi and 2 pi. But this is only going to be what it would look like. So I'm going to mark the center line. I'm going to dash it out. Is if there was no phase shift. So I don't even have anything marked off in pi over 6s. And my phase shift is pi over 6. And I got to stay between -1/2. If you want to put these little dashed lines in there, that's absolutely fine. And -2.5. My graph's going to be between here. Now, if I graphed the sign reflected, remember it's reflected, then it would start at -2, 0, and this is without a phase shift. It would go to like this. So I'm just dashing that in because that's not my actual answer. The hard part's going to be that we need to get where is this shift of pi over 6 occurring. So where is pi over 6 if you think about 0 to pi over 2? A third of the way, exactly. Because remember how that's referenced 30 degrees? And then the next one, 60, would be a multiple of that. So actually I need 2 marks in here. And the first one's 1 pi over 6. And the second one is 2 pi over 6, which is pi over 3. And then I need to split every one of these up like that into thirds. So I need 2 marks between my regular marks. Okay, now I can help you get this labeled quick. Let's go 1 pi over 6, 2 pi over 6, 3 pi over 6. 4 pi over 6 would be 2 pi over 3. 5 pi over 6 would be next. 6 pi over 6, that's pi. 7 pi over 6. 8 pi over 6 would be 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 would be 5 pi over 3. And 11 pi over 6. And then we have to shift to the right. We got to go past the 2 pi. So if that's 11 pi over 6, 12 pi over 6 is 2 pi. So the next mark, which is 13 pi over 6. That's where our graph will end. Yeah. So now I'm just going to shift all these points one little tick mark. Okay, so these points are just going over one little mark. One mark over. Each one. Pi over 6 units because we scaled it to pi over 6. And the last point will end at 13 pi over 6. Okay, so now our key points are pi over 6, negative 2, 2 pi over 3, negative 2.5, I'm sorry, I wrote, yeah, no, negative 2 is correct. 2 pi over 3, that's this one, negative 2.5. 7 pi over 6, negative 2. 5 pi over 3, negative 1.5, negative 1.5. And the last one's at 13 pi over 6, negative 2. When that's special. Yuck. I've seen worse. Shifting something 2 pi over 3 or something can be really gross. If something like this could be, this isn't that bad. I'm saying I'm not going to give you something really, really far out. All right, so then 17, so we got that one out of the way. 18, you're going to need to cut up very similar to what this one was. I don't know if we want to do that one or if we got something else we want to do. I think what we need to do, we definitely need, I can maybe leave 18, but I know I want to go over 19 and 20 with you. And then maybe a couple other ones on the back of 29. All right, so why I want to go over this one is in the past, we used to find our phase shift another way. And it was the opposite of C over, I even forget the rules it was, but because I'm not going to teach it that way anymore. So what we have here is a real problem because the B value's in here. See what I'm saying? It's distributed. And we don't want it. So we got to undistribute it. So we want to factor on this one. That's why it says we need to factor it. So that's what's written on your paper. It says y equals 3 sine. And then we brought the 4 out. And then theta's here. And then it said, well, what goes in this blank? Okay, so what I need us to figure out is 4 times what will give us pi over 2. You with me? All right, so I need to know what I got to put here so I can see what the phase shift actually is. So I say, well, 4 times something's going to give me pi over 2. Obviously, it's got to have pi in it, right? And what would 4 have to divide into to get me a 2? So I need an 8 down here. Because 8 divided by 4 is 2. You see how this would now reduce to this? Okay, so this is pi over 8. Not really all that bad for a graph. So we've got an amplitude. Let's write down what we got. We have an amplitude of 3. We have a b value of 4. So the period is going to be 2 pi divided by 4, which is pi over 2. Pi over 2 for the period. And it's going to have a phase shift, and it's going to go left. Oh, wait, is yours guys say plus? I want to make sure I'm not doing this right. Yeah, it's left pi over 8. All right, so let's make a horizontal axis. We have to shift to the left, so I'm going to bring my vertical axis a little bit in, give me some room on the left. Was there a center line change? Thank goodness no, so I'll leave it like I just drew it. This would be 0. The amp was 3, so we're going to go up to 3, and I'm going to kind of just write 3, and I'm going to write -3, about the same distance way down. We said the period is pi over 2, so I'm going to draw that out here since I'm shifting left. And then I'm going to cut that in half. Half of pi over 2 is pi over 4. Half of pi over 4 is what? Yeah, pi over 8. Oh, how convenient. Our x scale is pi over 8. So 1 pi over 8, 2 pi over 8, halfway between pi over 4 and pi over 2 would be 3 pi over 8. So now we know we're going to shift left, pi over 8. So we're going to be going to negative pi over 8. If you're comfortable just sketching the graph starting at the place that the actual graph's going to start, you can go for it. Otherwise, I'm going to just sketch it as if I didn't shift it, and then I'll shift it. So the sine would start at 0, 0, go up to its max, back to 0, 0, to the center line, down to its min, back to its center line. So as if you hadn't shifted it, it would look like this. And now I'm just going to slide my points left pi over 8. So this one up here is going to go to here. This one here is going to go here. Down here moves over to here. They just all, it's already in a scale that we want. Oops. And we end at 3 pi over 8. So the actual graph. What's that? Those points are negative pi over 8, 0, 0, 3, pi over 8, 0, pi over 4, negative 3, and 3 pi over 8, 0. Good? Yeah. You don't have to, but yeah, if you continued out to here, it would go like that. But you don't, I need these labeled. If you like labeled that and not those, all of those, that would be a problem. Because I need to know you know where one cycle starts with the shift and ends with the shift. Okay? Because you can actually extend all of these and they all match up. But it's, well, there's a, never mind. I think I said enough. Show me where the phase shift begins and ends in one cycle. And label those points. Okay, now 20. If I were to factor out, I have 1/2 cosine of 3 times theta plus pi over something. Okay, so 3 times something is pi over 4. I factored out that factoring out the 3. Oh, I think you guys have a different thing here, don't you? You guys have just pi, don't you? I just looked at my key and I was like, wait, there's no 4 there. Okay. 3 times something equals pi. What would it be? It'd have to be pi over 3. Okay. I think, is that, oh, and you have a minus sign here too, don't you? Oh, sorry about that. All right, let me fix this. I just realized that I had a different problem than you have on your paper. There we go. Better? All right, so start with an x-axis. Which way are we shifting? Right or left? Right, because it says minus right. So we're going to the right. So I can just start my vertical axis on the left. Okay, my center line is going to be 0. There was no vertical shift. But we're only going up a half. So if I make this be 1, this be -1, then we're only going up halfway to 1/2 and down to -1/2. The period, we did not decide yet. Period is 2 pi divided by the b value, which is 3. So it's 2 pi over 3. And we're going to have to shift pi over 3 to the right. So I'm just going to mark off 2 pi over 3 on my x-axis. Half of that's pi over 3. Half of pi over 3 is pi over 6. So my x scale is pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, will be labeled. I'm going to just talk about this graph now, right now, as if I'm not shifting it. All right, so I got a cosine, so I'd start up high, come to the midline, go to the min, back to the midline, and then up to the max. So this is as if it's not shifted. And if you're able to do the whole graph without showing that, that's totally fine. But how far over do we have to go? We're phase shifting pi over 3, we said to the right. So I got to take this key point and go all the way to pi over 3, which was 2 of my scales. My x scale is pi over 6. I have to move every point 2 pi over 6. Does that make sense? Okay, so I went 1, 2 marks. Now I got to take this point, go 1, 2, and put it here. Take this one down here, go 1, 2, put it there, right on my label. And then take this one, go 1, 2, right there. And then this one, 1, 2 marks. So it end here. Now I'm going to have to get those labeled in a sec. Sorry, I kind of made it a little bit too low here. Get my little eraser. Oh my goodness, I just messed up my label. Okay. Down here, and then I'm just going to make that smoother. There we go. So the key points, pi over 3, 1/2. Pi over 2, 0. 2 pi over, what was that? I forgot. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is 2 pi over 3. So 2 pi over 3, -1/2. And then this one, let's count. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So 5 pi over 6, 0. And then the last one, 6 pi over 6, which is pi. So pi 1/2 is the last point, key point. Okay, does anybody have a particular one they'd like me to look at now? Help you with? 21, sure. I was waiting for that. For one of these, at least. So what's a reciprocal function of the cosecant? That's the first thing I would think. Would be y equals 3 sine theta. You need to know that they're reciprocal functions. So if I can graph this, then I can graph this. So if I know what this looks like, then I'm going to flip it over. So I know this has an amp of 3. So if it's a sine wave, though, it would have started at 0, 0. It would have gone up to 3 at pi over 2, back to 0 at pi, down to negative 3 at 3 pi over 2, and back to 0 at 2 pi. So it would look like this if that's what I was supposed to graph, but I'm dashing it. Remember that wherever it's 0, that's where your asymptotes are for the cosecant. So I'm going to put a dashed line on the y-axis, a dashed line vertically at pi, because those are our vertical asymptotes, and at 2 pi. So every 2 marks, so I actually could continue it, but this is where one cycle is going to occur, so I'm going to graph it first. I take this upside down and turn it right side up and run along the asymptotes. This is a smiley face, so I make a frowny face over here, or whatever, just reverse it. And that's the 3 cosecant theta. And you could continue it by making a new another asymptote at 3 pi. And then realizing it'd be a loop up in this section. That's the end of that. Oh, the point here would be pi over 2, 3. This one would be 3 pi over 2, negative 3, and those are the only ones you got to label. These, most of them are going to be sine and cosine. Oh. How there's already things marked off? Yeah, where you have to make your own. I hate to say it, but you got to make your own. Well, I'll have them there when we make a quiz like that. Well, I'll check if I can modify it. I'm not sure. No, I know what you're saying. I kind of like these. Do you prefer this? Yeah, than doing it yourself. Now, some people would say the other way around, but I get it. In the past, it's been where I make one of those and one of these. Yeah. Scott? If you have an if you have an amplitude that's negative, instead of going like this, it's going to go like that. Reflects over the x-axis. Okay, I'll do some more problems, but that's all I'm going to record today.